Hello students, welcome to another video lecture on logic design. We are in the process of studying binary arithmetic, in particular binary division. There are two methods for dividing in binary, the paper method and the computer method. In this video, we will learn the computer method for dividing two numbers. This method involves successive subtraction. So you have to be able to subtract in binary. If you need to brush up on binary subtraction, please stop this video and look at the video on binary subtraction. This method assumes the use of two registers. As I have mentioned before, a register is a storage space in computer memory with a certain size capacity. For example, I can have a register named as the accumulator and it can have a size of 16 bits. I can use this register to store the results of any arithmetic operation, but I can store only 16 bits of information in it. So in this computer method, we will make the use of two registers. The dividend or the numerator will be stored in the MQ register and the divisor or the denominator will be stored in the M register. So I am sure that you have enjoyed the video on computer method of multiplication. So without a doubt, you will enjoy this one as well. Let us take an example and divide the following two binary numbers. When dividing the two numbers, the first number is called as the dividend and the second number is called as the divisor. In the previous slide, I mentioned two registers. The M register, which contains the divisor 0101, and the MQ register, which will contain the dividend. Now, the dividend is 100000 and I fill the MQ register with the dividend. Notice that the first two bits of MQ are empty. So we fill that with 0. Now, whenever a computer is supposed to execute something, we have to give it an algorithm or a procedure to follow. So what we need is an algorithm. The first step is as follows. Subtract MQ minus M. Let's do that. Notice when we are subtracting M, we subtract it from the top 4 bits of MQ register. The answer that we get is. Also, during this subtraction, notice that there is a need for a borrow. Step 1 of the algorithm has an additional step which looks like this. If there is a borrow, the answer is negative. Division is valid. Add M to MQ. If there is no borrow, answer is positive. Division is invalid. Add 1 to MQ. Coming back to our example, in the process of subtraction, we notice that there is a borrow. So since there is a borrow, we need to add M to MQ. Notice that we are adding M to the top 4 bits of MQ. On adding, we get there is a carry out of 1 which I have marked in a grey square. Your algorithm calls to ignore this carry. We are now ready for the next step in the algorithm. Shift MQ left by 1 bit. Shifting the contents of MQ 1 bit to the left looks like this. The bit which is shifted out is highlighted in a yellow square. So since we have shifted 1 bit out, another bit has to enter from the right side. Let's put that bit as 0. We are now ready for the next step in the algorithm. This process is repeated p times, where p is the number of bits in M register. Let us recall that M register contains the number 0101, that is equal to basically 4 bits. So we need to repeat this entire process another 3 times. So let us start repeating the process. Start from subtract MQ minus M. We get, notice that we require a borrow during the subtraction. Therefore, as per step 1 of the algorithm, we need to add M to MQ. So go ahead and add M to MQ. We get the answer as this. Notice that there is a carry. We'll ignore this carry. Next, we need to shift MQ left by 1 bit. Shifting MQ left by 1 bit looks like this. Since we have shifted 1 bit out, another bit has to enter from the right side. Let that bit be 0. This completes 2 times of the entire process. Stay calm and do the same thing for another 2 times. Starting the algorithm all over again, subtract MQ minus M. We get the answer as, notice that during this subtraction there is no borrow. So as per step 1 in the algorithm, if there is no borrow, the answer is positive, the division is invalid. So we need to add 1 to MQ. Notice that while adding 1, we add 1 to the LSD. We get the answer as per step 2 of the algorithm, we now need to shift MQ left by 1 bit. So shifting MQ left by 1 bit looks like this. So since we have shifted 1 bit out, another bit has to enter from the right side. That bit is 0. This completes 3 times of the entire process. We need to repeat this one more time. Subtract MQ minus M. We get the answer of subtraction as this. Notice that during subtraction there is no borrow. So as per step 1 in the algorithm, we need to add 1 to the LSD. So go ahead and add it. We get the answer as this. Step 2 of the algorithm now tells us to shift MQ left by 1 bit. It looks like this. Since we have shifted 1 bit out, another bit has to enter from the right side. That bit is 0. This completes the number of times we need to repeat this process. We are now ready for the next step in the algorithm. The next step of the algorithm is very similar to the first step. So let's just go ahead and do it. Subtract MQ minus M again. We get the answer as this. Notice that during subtraction we'll require a borrow. So as per the step, if there is a borrow, the answer is negative, division is valid, add M to MQ. So go ahead and add M to MQ. We get the answer as this. There is a carry of 1, we ignore this carry. So the remainder of the division is in the left half of MQ, and the quotient of the division is in the right half of MQ. So we get the remainder as 0010 and the quotient as 0110. That's all for now. Try your hand in dividing the following binary numbers. Connect to the classroom for further videos and learning material.